So basically what we're looking at here is leafcutter ants. And what you may not know about leafcutter ants is they don't actually eat the leaves themselves. They're farmers, and they use the leaves as fertilizer in their fungus gardens. And they've been doing this process for over 50 million years. And just like how we farm, we have to keep the pests out, these ants are using antibiotics that live on their bodies in order to maintain their gardens and keep them healthy. But the thing that's most interesting for us as scientists is even though they've been using these antibiotics for 50 million years, they haven't had the same resistance problems that we've been having with just using the antibiotics for 100 years. So there's a big difference there. And how we're going to figure this out is if you look over here, you have the actual picture of the antibiotic at work. So the antibiotic lives on the ant as a bacteria, and the bacteria secretes the substance which will kill the bad guys. And there's a very delicate balance that's happening here inside the gardens of basically ant versus good bacteria versus bad bacteria, and it's a very complex relationship that's been going on, as I said, for millions of years. Now, if we can isolate that kind of mysterious compound, we can figure out what exactly the ant is carrying on its body that's going to kill the bad bacteria, as you can see here with these halos. But I think the most important thing actually is, as humans, when we think about infections, we think, okay, nuclear war, we've got to kill all the bad stuff, just kill it all. But it's not working for us. We're getting that resistant bacteria. The most interesting thing here is that in this complex relationship, if any single microorganism, whether it's the ant, the good bacteria, or the bad bacteria, start to overpower the system, the ants will actually change which antibiotic they're using to restore the balance of this system. Now, if we can figure out chemically what's happening and microbially what's happening, we might be able to develop drugs that are more like a cocktail of good and bad things that will restore the balance in our bodies and not just kill everything.
So I think that these ants kind of resemble red ants, don't they?
Around here we have red ants, but leafcutter ants are native to Central and South America, so you're probably not going to see any of them up here.
And then I was saying that I thought that this kind of mirrored what one of your classmates was doing with the dandelion. So how is the process the same?
So basically, this is actually one of the things we learned at SURP. It's called TLC, which is thin layer chromatography. And you can do the same thing with ants or dandelions or any kind of plant. You basically make some plant or ant soup, you condense it down, you separate out the chemicals, and then you can scrape each individual compound and then test it against the bacteria, in this case it's staph, and see if you develop these halos. If you got the halos, you've got the magic. That's where you're looking at, exactly.